Actually. Oh, so I just click.
We're right for seats. Excellent. All right. Well, thanks everyone for coming to the I don't know what number East Sydney event. But first, yeah, I'd like to pay my respects to the original custodians of the land on which we stand, the Gadigal people of the Eora Nation, and pay our respects to their elders past, present, and emerging. A special thanks, of course, to YBF for hosting us. Thank you, Courtney. Much appreciated.
Our pleasure.
And also for sponsoring the food and drink. Yeah, it's really helps. Yeah, let's get started. Thank you so much, Jan, for coming. You're here DJing, doing cool stuff anyway. So that was really cool. You got to drop in and tell us about the other cool stuff you do. So
yeah.
I'm not sure if you got your intro slide, but I won't.
I sort of do.
Yeah.
Also, if anyone wants seats, there's 3 here, 2 in the front row, and 2 on the side. Yeah. So no one should be left standing.
Come on, guys.
All right.
Yeah. All right, take it away. Thank you.
Thanks. How do I
That's right.
Oh, here we go. Thanks. Cool. So my name's Jan. I run the security team at Brave Software. How many people have heard of Brave? Oh my God, almost everyone. How many people have heard of the basic attention token? Okay, almost pretty much the same set of people, which makes sense because they're related. So Brave is the creator of the Brave browser and the basic attention token. We're based in San Francisco, and I think this is our first time giving a talk in Australia. So congrats on being here. So a lot of people, when we talk about Brave, ask us, why do we need yet another web browser? Because obviously there's Chrome, Firefox, Safari, Opera, Vivaldi, Lynx, probably a bunch of others. And kind of the premise of Brave is that the web is fundamentally broken in some ways. One of these ways is advertising. So this is a website called the $1 Million Homepage that was made by, I think, a teenager who had to pay for college. So he decided that he was going to raise $1 million by making a page and just cramming as many ads into it as he could. And so the page ended up looking like this. So he basically sold each of these like little squares for $1, or maybe it was like $5 or something. And he, oh yeah, $1. Oh, $1 per pixel, right? So I guess like these actually cost much more than $1 because there's a lot more than 1 pixel per ad. But anyway, he eventually did raise $1 million by doing this because it went viral. But yeah, so anyway, this is an ad-funded website. It's very obviously like very unpleasant to look at, and there isn't much like real content on it. And so this is sort of a parody of what many web pages are these days. So the truth is, websites today are mostly funded by ads. And ads are not as simple as just, you know, this page shows where you go to a website and it has some images hosted from the ad company. Actually, there are a bunch of parties involved in serving up ads. So when you go to a website, the website actually goes to something called a supply-side platform, which gets the ads from the ad exchange. And on the other side of the exchange are demand-side platforms, and that's who marketers pay to get onto the ad exchange. So marketers basically make bids for your attention, but depending on who bids the highest amount, that's whose ad gets shown to you. So the key point here is when you visit a website, you're not just leaking data to the advertiser. There's actually these other platforms that are getting your data as well. And this slide basically shows the same thing. So when you go to a page, there's all these requests, hundreds of requests that go out. And you might wonder, so when you make ad requests, what amount of data gets leaked? There is a specification for this called OpenRTB. And most people obviously don't read deeply into this, so I'll just point out some of the fields that are in the spec. So obviously there is the domain that you're visiting when you get the ad. there's all these IDs which are used to uniquely identify individuals. There's things like year of birth and gender, your IP address, the device ID string, user agent, details about your phone device. And sometimes it could even include latitude and longitude, so precise location of the person. And this is used to help target the ad to your specific interests and location and profile. Besides that, ads are slow, so they can take up to 5 seconds per page. Pages can include over 100 trackers, and all this adds up to bandwidth costs. So $23 a month of bandwidth can be used just for downloading ads if you're not using an ad blocker. And in recent years, we've seen malware spread through being propagated via ads too. And as a result of all these things, who here uses an ad blocker? Just raise their hands. Yeah, so pretty much everyone at this point. So in recent years, the ad blocking has grown really, really significantly. So in case you can't see the x-axis, this is 2011, and then the far right is 2016, which is 3 years ago. And I'm pretty sure like if you keep going, it just keeps going up and up. The orange line is mobile. So since 2015, mobile ad blocking has especially gone up, probably because people realize like, this has huge bandwidth costs on mobile. So kind of a premise of Brave is that all of this is very broken. It's not very friendly for users. Ads don't usually act in the interests of the people visiting the web page. So using some clever techniques and blockchain, we can make a better web ecosystem. So Brave, if we had to summarize it up in one sentence, we can say it's a privacy-focused browser that tries to pay content creators while putting the user first. And paying content creators is important because the problem with just blocking ads is you're cutting off revenue to the people who are running the ads, right? So people embed ads in their website so they get paid by advertisers. But if you block ads, then those people aren't making money. So content creators have to still make money somehow. From the user's perspective, there are some benefits of Brave. It's faster largely because we block so many ads. It gives more control over users. So I'll talk about this in a bit, but we actually have a setting that lets you opt into like privacy preserving advertising, but that's not the default. There's better security. And then finally, there's like data and bandwidth savings because of ad blocking. There's also some other privacy benefits like blocking third-party cookies, blocking requests to trackers using these tracker blocking lists. It's fully open source. So Brave is based on Chromium, but we block the network requests to Google. So you can think of it as Chromium, just the open source parts of it, minus the parts that have Google integration. So obviously, like you can log into Google and Brave, but by default, we try not to make any requests to Google. We use HTTPS everywhere to upgrade HTTP requests when possible. And we try to block fingerprinting, which is a method of that websites use to recognize what kind of device you're on. All right, but the key part of Brave is solving the problem of web monetization while putting the user first, because that's sort of the problem that hasn't been solved by ad blockers. So like I said, when you run an ad blocker, yes, you get all the benefits like speed and privacy, but the website that you're visiting isn't making money. So we want the websites to keep making money. So how do we do that? A key part of that is BAT, which stands for Basic Attention Token. And we just pronounce it bat, like the animal with wings. So this is an ERC20 token. We raised 36 million during an ICO in 2017. And a really cool part of that ICO is we allocated 50 million in BAT to a user growth pool. So that 50 million, eventually we give back to users in order to incentivize them to try out Brave. And a lot of that ends up going to creators because users can donate BAT to creators. So yeah, ERC20 based on Ethereum. Cool. So we have a system called Brave Rewards. So users can get BAT when they either claim a grant, which comes from the user growth pool that I mentioned on the last slide, or they can earn BAT by seeing ads. So a key part of this is when an advertiser buys an ad through Brave, part of that ad revenue goes to the user. So users who choose to see ads can actually earn money for seeing them in the form of BAT. And that goes into their browser wallet. And then when users want to spend their BAT, they can either spend it by giving tips to publishers, or they can say, I want to auto contribute to sites based on how much I visit them. So there's actually a setting called auto contribute where you don't have to think about who to give BAT to. The browser just locally measures which sites you're spending the most time on and allocates BAT to them. So you can think of this as a system for replacing the revenue lost by ad blocking. Because when you visit a site, instead of paying them through seeing ads, you're paying them by tipping BAT. And this is all opt-in, by the way. So if you don't want to do any of this, you can turn rewards off, and then it's just a normal ad blocking browser. And on the other side of it, websites can sign up to receive their BAT. So we actually collect BAT for websites, and then if it doesn't get collected, it goes back to the users or back to the pool that it came from. But if websites sign up, they can get their BAT, and then through our partner Uphold, they can convert that into fiat pretty easily. We've been getting good traction with getting publishers on board. So just this year, our biggest publisher, which is Wikipedia, signed up. So now if you visit Wikipedia in Brave, you can donate tips to them using BAT. Also Dow Jones, The Guardian, Washington Post, Vice, and some various other sites. If anyone here runs a website or has a YouTube channel or a Twitch channel or even a GitHub account, you can sign up. Or, oh, actually, yeah, we support Twitter now. So even just the Twitter account, you can go to creators.brave.com and sign up today to get BAT. And if you run a big site, you might find that you actually already have like a significant amount of BAT like waiting for you. We're just not very good at like notifying you sometimes because we don't know how to contact you if you haven't signed up, obviously. So ads, I mentioned previously that you can opt into seeing ads. We try to do this in a way that's not very intrusive and doesn't take much bandwidth, and also has some like privacy benefits, which I'll get to later. But from the user interface perspective, ads are currently just these system notifications. So that way we're not injecting content into websites or making like the websites look worse. It's just this like completely separate notification. And what's really interesting about this is that there's no network requests. So we have a cool way where we download the entire ads catalog and then do all of the matching locally. So this ad that you see is like completely loaded locally, and there are no network requests. The only network request is if you actually click on the ad and then you go to the landing page. And obviously we have to make a network request to get the website's landing page. But until you do that, there's no privacy downside because we're not loading anything. So here are some stats. Currently, we just passed 9 million monthly active users, mostly on mobile, over 8 million BAT wallets. On the publisher's side, we have 300,000 plus verified channels. And these ads have been seen over 99 million times, and 14-ish% of the time people actually click on them. So if you know much about the ad industry, like 14% is really high. Most of the time it's like 1% or so, or less, I guess. And the whole point of this is like, I think this means Brave is actually one of the most popular like cryptocurrency applications that non-technical users use, because a lot of the people using Brave, they don't have cryptocurrency wallets otherwise, and they're not like technical users, right? So our goal is really to reach people who wouldn't otherwise be interested in cryptocurrency. Oh, and we actually just launched Brave 1.0 right before I came to Australia, which was like 2 weeks ago. And Chrome sent us a cake. They sent us a cake that says, congratulations on loading Brave 1.0, which was very nice of them. All right, so the next part of this talk gets pretty technical, and I'm actually gonna, okay, plenty of time. So, so the goal with Brave ads is we want relevance, because if you're seeing a lot of ads where it's something that you don't care about, then you're gonna turn off ads, right? A lot of people on Facebook used to see ads for Amazon products that they had just bought. And so that was like a pretty bad user experience because you're like, why would I want to buy that? I just bought that. So relevance is making people see ads that they actually care about and hopefully are something they're actually interested in buying. At the same time, we want privacy. And by privacy, we mean that both Brave itself, the server that Brave runs, and advertisers should not know what a user's interests are. So by that, we say, we call that a segment. So segments can be things like cars or houses or medicine. When advertisers build a profile of you, they put you into these segments. And what Brave wants to do is we don't want to link you across these segments. Yeah, so if you interact with one ad for cars and one ad for houses, we shouldn't be able to build a profile that you're someone who cares about both houses and cars. So on the topic of relevance, so how does Brave pick which ads to show? I mentioned earlier that basically for privacy reasons, we download the entire ads catalog for every user. And then we do local machine learning to figure out what segments a person is in. So the key part of this is instead of being this surveillance company that looks at what websites you visit and tries to build a profile of you, we just use the browser, because the browser, like your browser has a perfect view of all the websites you're visiting, right? Because you can go to your browser history and it lists all the websites you're visiting. That data doesn't need to get sent to any advertisers. In fact, like that data can just be mined locally to figure out what your interests are and classify you into segments. So none of that data needs to leave the device. All that is done locally. And then because we have the entire ads catalog already downloaded, the Brave client just looks at what your interests are and then picks an ad which matches those interests and shows it to you. And the key part is like none of that data has left your device. All of this is still just happening locally. All right, and then another thing we do, which is kind of unique, is we pay users for seeing ads. And so you might ask, well, how do we reward you for seeing ads if we don't know what ads you've seen, right? Because then you could be doing fraud, you can be pretending to see way more ads. And so how do we do this thing where we don't want to link you or build a profile for you, but we have to be able to pay you for seeing the ads that you've seen? And we do that using magic, aka cryptography. So this gets a little complicated, but so we use a thing called, well, actually we don't use plain RSA, but RSA is a good example because a lot more people are familiar with it. So RSA, how many people have used like PGP or have some basic familiarity? Okay, so that's like maybe half the audience. So just as a refresher, RSA, is a public key crypto system. So there's a public key, there's a private key. The public key is what you give to everyone, and then the private key you keep private on your device. And so the first two lines of this are just your public and private key. And in RSA, that's used both for encryption and for signing. And for our system, we also have this thing called R, which is a random number, and M, which is a random token string. And token in this sense is not the same as BAT. So like forget about BAT. This is a completely different token. All right, so what we use is something called blinded tokens. So by blinding the token, we basically just multiply the original token by a random number exponentiated. And the client does that, and then it sends the blinded token to a server which Brave runs. And the server just does an RSA signature over the blinded token. In step 3, the client gets the signature back and divides out R to remove the blinding factor. And then because there's this special math that you can do with RSA keys, what you end up with is, after the unblinding in step 3, is you actually get the server's signature over the unblinded token. So that's kind of a diagram showing that. So the client sends a blinded token, the server signs the blinded token, and then the client unblinds the token and has an unblinded token. You might wonder, like, why is that useful at all? Like, why do we care? The reason why this is so cool is that at the end of this process, the client has a signature from the server over the unblinded token, M. But the server, because it signed the blinded value, does not know what M is. It only knows M prime, which is M multiplied by a random factor. So it's completely unrelated to M. So So the server, the client has a valid signature over a value that the server doesn't know what it is. And how is this useful? Well, okay, so here is a slightly simplified example. Say that we're trying to do anonymous voting. So let's say like we have an election system, we want people to vote, but we don't want to know what parties that people are voting for. But on the other hand, we don't want people to submit too many votes. So let's say we only want each of you to submit 5 votes per day. And the server should not know which 5 votes are coming from the same person. So we can do this. We're going to have the client generate 5 tokens every day. We can have the client log in and then blind the tokens and send them to the signing server. And then the server verifies that this logged in client hasn't already claimed 5 tokens. And if that's the case, then the server signs the 5 tokens and gives them back to the client. Now the client can remove the blinding factors and get these 5 signed unblinded tokens. So later when the client wants to submit a vote, it can log out so the server doesn't know it's the same client, and then send the vote with one of the one of the signed unblinded tokens. And because the server doesn't know what the unblinded values are, it doesn't know that which client that was logged in requested that token. So basically, it's like this unlinked token at this point. And the server can also verify that it has signed the token. So it can verify that signature to make sure the client isn't going over the 5 token per day limit. So anyway, this is kind of complicated, but the result is that the server ensures each client can only vote 5 times per day, but does not know which votes are coming from the same client. So we call this authorized but anonymous, because the server does the signing to authorize the clients, but the thing that is submitted in the end is anonymous. And so this is kind of what we use in Brave. See if I have a better slide. This one is not useful because it's too complicated. Yeah, so basically this is what we kind of do in Brave. So the client regularly asks for signed tokens, and each time it sees an ad, it uses a signed token for authorization. And so the server can make sure like, oh, the client isn't pretending to see like 1,000 ads, because each client can only get like 100 tokens per month or something. So that's kind of our rate limiting for ad confirmations. And the server validates the token and then returns a signed payment token. And then clients can collect these payment tokens and then later submit these to redeem for actual BAT. So basically through this process, clients are submitting tokens every time they see an ad. The server gives them these payment tokens equal to the amount that the ad is worth. And then at the end of the month or whatever the payment period is, I think it's a month, it might actually be 7 days, the client can submit all of these payment tokens and get that redeemed for actual BAT. And we actually have some additional like server-side anti-fraud processes to make sure that like there's no BAT wallet that's claiming like $1,000 or some like ridiculous amount of revenue from seeing ads. Because if you're a real user seeing ads, there's only like so much money you can make from every month from doing this. Yeah, that's our CEO, Brendan. He has a brain chair. That's all that slide is. Someone I think on Reddit made this. Cool. I don't want to spend too much time talking about this, but basically like Brave also has a protocol, as I mentioned, to automatically contribute money based on how much time you've spent on sites. And this uses a similar thing to blinded tokens, because we don't want to know your browsing history, but we want to know like what sites to pay. So if you're spending like 3 hours on YouTube and 2 hours on Twitter, and you want to send them a certain amount of BAT based on that time split, we want to be able to donate BAT to those websites, but we don't want to know that you're spending this much time on this person's YouTube and this much time on this person's Twitter. So this also uses a similarly anonymous thing. I see there was a question. I think we're going to do questions at the end. Yeah, which is coming up. The end is soon. Yeah, this uses anonymized, but the slide isn't relevant because I think we're getting rid of that. Yeah, so as you browse, Brave keeps this local table of how much attention you've spent on various websites. So in this like extremely boring example, you've spent 60% of your time on brave.com. And for some reason, the other 40% of your time, you are on Brave's YouTube channel. So we keep that table. And then let's say you spend 5 baht a month and you say, just, Brave, figure out how much to give to all the sites I've spent. Yeah, so we divide that, 60% of 5, I guess, is 3. So we would give 3 baht to brave.com and 2 baht to Brave on YouTube using these anonymous surveys. So, yep. Yeah, and then everyone's happy because Brendan has given you baht. That's pretty much it. Oh, and I have one more plug, which is Mr. Bill, who is in the audience, and I and some other people are playing a show tomorrow at the Lair. This is electronic music, not cryptocurrency. So you should go.
What kind of music? Very cool music. We'll put it on in the break.
Yeah, it's electronic music, bangers. Yeah, there's this guy, Prowl plays drum and bass. Yeah, there's everything, you'll love something in it. I don't know. I don't know yet. Cool. Cool.
Thank you.
Yeah. I think I've, all right, questions. You were first, so yeah, you can.
Is the server open source?
The servers are mostly open source. So I think there's some parts that are closed source because they're anti-fraud. But yeah, most of the servers are open source.
And how do you protect against like alternative methods of de-anonymization? So
like IP address and timing.
At the end of the month you go to submit and you've got the same IP address.
Yeah, so that's a really good question. We try to time it. So we try to do this thing where we look at like how much time do we have to put in between requests such that we can't tell that people are coming from the same, are like the same user. So obviously if you submitted all your votes at the same time, it would be obvious like all the votes are coming from the same person. So that's why we add like a random delay to make that less likely. And then for IP address, we don't have a great answer. So currently we use a Fastly proxy. So the Brave server itself doesn't see the IP address. But that's not ideal because if we go to Fastly and we say like, show us the IP addresses, then it's the same thing. So that's what we do currently. But ideally we could like use Tor or something to hide the IPs. Yeah, sorry, I think you were second. Oh my God. Okay, let's start with one and then maybe like go to.
All of them are about UX.
Okay.
I'll start from the main least important. So I'm using Brave on mobile, and I see this little number saying 5 on top. I have no idea how to donate it to somebody.
Wait, where do you see 5? Like in the browser? Like
in the top right corner, red dot saying I have 5 bats probably.
Oh, are you on iOS or Android? Android.
So I have no idea how to donate them. That's UX problem. I really have no idea what's happening when I'm clicking.
Okay.
That's one thing.
Okay.
That's not even a question.
Yeah, that's a comment, not a question.
I was about to ask how to use it, but let's.
Okay.
The second thing about the same application, if I'm using Chrome browser as a default browser, I click on the link in any app. If it's a YouTube link, I will open the YouTube as an app. With Brave being a default browser, it doesn't happen.
It doesn't open in the YouTube app, it opens in Brave. Okay.
Which is very inconvenient, and I'm thinking of dropping using Brave.
Okay. Cool.
And some other similar apps. So that wasn't also a question.
By the way, yeah, we do like having feedback like this. Yeah.
Can you ask them to fix that?
Yeah, I can definitely ask the person who is in charge of Android to look at this.
So our company is using support the intercom. That's intercom.com.
Yeah.
Very handy. Gathers a lot of information about our users, and we see what pages did, their type of browser, etc. And chat is the main feature of it. And Brave blocks it.
Yeah, we do. They actually reached, I think Intercom reached out to us asking us to unblock, and it's actually not super, like we could obviously unblock them, but we just use ad blocking lists from like other people.
They do track users from website to website.
Yeah.
And I see that.
And that's why they're blocked, right? Like they're literally blocked because like scanners notice that they're setting like very high entropy cookies on a lot of different domains.
Yeah, but this breaks our business, and we do not recommend users to use Brave browser just because it breaks our support. The only support.
Yeah.
Can you deal with it somehow?
I mean, honestly, the best we can do is like say, like, because that is like legitimately a tracking thing, right? Like it might be tracking for good intentions, but it's still tracking. You could tell people to turn off blocking on your website. You know, you could say users like go to this one-click thing where like it turns off Brave blocking on that page. I mean, you might be able to just run a proxy to intercom so it doesn't, so it's like a first-party tracker instead of a third-party tracker.
Okay.
Yeah, that's probably the first thing I would suggest is like trying to run a proxy somehow. Sorry, I think you were next.
Sure, I'll take one.
Yeah.
Well, 3 questions. First off, I'm
Oh my
not
God.
here. But second question, out of curiosity, how do you deal with anti-fraud? For example, what's stopping a hacker or malicious person from spawning up a bunch of, because it looks like it's very much client-driven with a
Yeah,
server-side component.
like why can't someone run a bunch of
clients
VMs?
that
Yeah.
are going to kind of hit a certain site or collection of sites, like maybe some rogue days to set up a whole botnet of sites they want to
Yeah.
hit, and collecting all that awesome Bitcoin or Bitcoin or
Right.
cryptocurrency for themselves.
Yeah, so that's a really good question, and I can't give a full answer because this is being recorded, and like the fraud people will look at it and be like, "That's how we circumvent your fraud." Anti-fraud. Yeah. But yeah, so like,
Can you answer that one later for me?
yeah, sure.
Other crypto questions I have.
Yeah.
Thank you.
But yeah, I mean, the short answer is like, if you're trying to pay yourself through auto contribute, you have to have a website to like to ultimately get the money out.
My point was basically they would spin up a bunch of these rogue websites,
But we-
and then try to find a way to just automate the whole process. So I'm sure there's
Yeah.
something.
No, people have tried this, and like people have tried exactly what you're saying. And in that case, we actually will look at websites that are making a lot of money and look at them and be like, is it feasible that this random website is making like $1,000 a month? And if not, we can, in our terms of service, we can say like, if it looks suspicious, we'll like withhold your bat until later, which some people aren't happy with, but
Okay.
yeah. Yeah.
Everything's decentralized these days, I heard.
Yeah.
All right, off. Thank you.
Sorry. A few more, I guess in the back.
So you said earlier that Chromium phones go to Google.
Yeah. Or sorry, Chrome phones home to Google. Yeah, Chrome does. Chromium actually has many components that do make requests to Google, but Chromium doesn't have Google accounts built in. But yeah, it does. Chromium, even if you're just using Chromium, it makes requests to Google.
So you guys use Chromium.
Yeah.
And you block the calls to Google.
Yeah, pretty much.
Instead of just factoring out the code.
Well, sorry, by block, I do mean like a combination of like blocking and just removing the code that does it. So we support extensions, and our philosophy is kind of like, if you install extensions, that's like on you to figure out what they're doing. And yeah, because extensions are kind of like opt-in. So the goal is like Brave out of the box should not be making calls to Google. We support MetaMask actually. Yeah. Yeah, sorry, I think we only have like one more.
Sure. It was just a quick one on the machine learning classification that you use, whether or not you have any kind of extended literature that I could peruse, because it don't want to
can you email
all your time.
Yeah, I'll give you, well, you have my email, but I will have to ask people to try to get that because I don't have it offhand. Yeah.
Off the back of that, yeah, around the analysis of the local data to then choose what. So is that somewhat extensible? Can another, like a third party module, do a similar thing, or can you change the algorithms?
Larger the point of my question.
Yeah.
Yeah, right.
I don't know the answer offhand, but I could email and try to give you an answer. Do we have time for more? Okay, cool. Yeah.
Brendan Eichhammer on Reddit last week mentioned that you're using the Tor protocol.
Yeah.
So you ported the Tor protocol to Chromium from Firefox?
So Tor is, well, two things. So one, it's like a proxy. So it's just a SOX proxy. And then it's also like a set of patches to Firefox to make it like more privacy preserving. So what we did was we made the proxy usable in like private windows. So you can run normal Brave and then you can open a window that just runs Tor. And then we also added some of the privacy improvements from Tor browser, but not all of them. So
Because that would address the first question about IP.
yeah. Yeah, well, the problem is a lot of companies don't let users. So Brave has actually been blacklisted from a bunch of like corporate networks because they noticed it had Tor built in. And so a lot of people just can't run Tor. So like if we use Tor to hide IPs, we couldn't do that for everyone. And that's part of why we haven't done it. yet. But yeah, I think in the future that'd be a good like option for people who are able to run Tor.
Cool.
Final question.
What's the best way to grow? How do you see yourself in 5 years?
Yeah, I mean, I think the biggest one now is like Brave. Like he said, there are some usability issues. Like we have to solve those, and then kind of start to message to people outside, like the technical and like cryptocurrency communities. Word of mouth. We've also been. We actually recently just hired more marketing people, so like doing more traditional marketing campaigns and such.
Can you tell us, because we like small companies, not as big as Brave is, so just tell us a secret.
I actually honestly don't know the secret. I think it's just you have to grind for a long time. Yeah, it's just a lot of grinding.
Cool. Thank you very
Yeah,
much.
thank you. Thanks. Yeah.
Get a little break. We've got some food here as well, so grab yourself the Subway and yep.
Cool.
Very much.
Yeah, thank you. That was a good question.
Don't let you go.
Yeah,
on
thank you.
without subscribing or ad block for the last few months.
Yeah,
I haven't downloaded Brave yet, but I'm downloading it for Wapo.
I'm actually not sure if
To get back there.
yeah, I'm not sure if you download Brave, like if the ad block thing goes away. I think it might, but I'm not sure.
Yeah, I don't mind the ads. I just want to get home to Washington Post.
Yeah.
They stopped you from accessing in private windows and stuff. So if they're on board, if you get those kinds of key players that manage to slow down the subscriptions on other browsers,
Yeah.
I reckon that's a winner.
Yeah, that'd be great. Like get around paywalls.
Thank you so much.
Yeah, thank you. Our what?
My questions are crypto related. The third one
Okay.
was, do you have a white paper?
Oh, on that, yeah. So if you go to like basicattentiontoken.org, like there's literally like a white paper on the front page or
I
something.
mean, not so much for is it for that token essentially, or is it also for everything you run the client side encryption and things like that?
So most, it's kind of spread out. So like we have a wiki that has most of the things I just said, but it's not like one paper.
Zoom，然后接在 YouTube 上面。
Because there's
这个就一贴去，你们都是直接放那个 YouTube 的。
在 Zoom 和
I'm
YouTube
curious
上面。
because believe it or not, what you guys are trying to create.
我看到没有人拍照片，我就一个人。
We're trying to make a
Not
browser.
I was trying to make a browser that gets rid of
这个科技
basically Iridium, but even Iridium might not.
应该
Oh
可以
yeah,
吧？
yeah.
Except
Iridium's
that's
pretty cool.
Iridium's alright, and you put an ad blocker on it. The other question is about, okay, it's assume Iridium. Well, then it's
I mean,
There's a
Iridium
lot of
has
content creators,
has
but-
some like privacy things that we haven't lifted yet, and like they have an issue with this.
这个
Here's a list
你
of
可以
things you
用
should
它
ask
这
for
个。
Braves. It's the same as Iridium.
Sorry, Iridium do what they do. You guys what you do. My question would more be about your model seems to be more for reporting content creation.
Yeah, it's more
like
about
that,
like the
which is kind of shifting, I guess, the
How many
ad companies.
users of Brave browser actually make some?
make payments. I don't know. I could look up. Well, so I told you like there's 8 million wallets that have ever been created. I think there's probably about like 4 or 5 million active wallets. So that would be, so there's 9 million users, so that would be like 60%.
How would you, same question, like how would you like grow from let's say 1,000 users towards what would you do? What's the strategy of
Do you
Brave?
mean that like what we already did? Because we already grew up to like.
Yeah, and then how do you guys made it?
How
Just
do we
money?
do it? It's a good question. It's a lot of marketing, I think, because so part of it was like Brendan was already famous because he like created Firefox or like helped create Firefox.
Just wanted to be different, right?
Yeah, it was like partly that.
You hungry, by the way?
No, I'm good. Yeah. Well, if you guys are, I don't get it. Yeah, right now. Oh, like.
Yeah, just reading a market. Oops. Sorry. Here, I put. Okay. It's
Does it work?
recorded. It's work. Left and right.
This one?
Oh, yes,
Everyone, grab a drink before you sit down. Got some more beers there. Grab another sub if there's any. Our next speaker needs no introduction. He's the CTO of AlphaWallet.
Thank you very much.
No. Take it away.
Thank you. Thank you very much for coming. Thank you for James organizing the event. Thank you for James who supported me, and thank you for James, my colleague who. Yeah. Okay. So James once told me that I perform better if I drink a little bit, otherwise I'm too stiff. But I perform terribly if I drink too much, because that would be stupid. James, will you take a note? Today I had 8, so you can find a balance point next time between 4 and 8. So today is 8, okay? So here we are talking about Web3 and we're talking about security. And I'm picking up from Brief to talk about privacy as well. So I'm going to briefly look at, I assume that you guys knows about Ethereum and how DApp works today. So this is briefly how we got here today. So Vitalik was the star that was born out of Big Bang, nowhere, and he has this idea of a smart contract from nowhere, and then it worked. But he's asking the question that how do we provide user interface for smart contract? And that was the start of Web3. So the idea at that time was, why don't we use JavaScript and HTML? This is the user interface language that people are mostly familiar with. So yeah, we do it HTML and JavaScript. Then the next question is, where do we put them? Apparently, you cannot put the HTML and JavaScript on the blockchain because it would be too fat. So let's put it somewhere in the website. That was the answer at that time, roughly 2016. And then we need, because website is actually doesn't belong to the users, right? If you say token belongs to the user and the smart contract is a public domain, then website is neither. So it's in the security limbo. So there's naturally a question that how do we limit access, the website's access to users' information? The answer is we simply ask the users. So if you visit the DApp will ask you, do you want to send the address, the Ethereum address to the website, or do you want to send your token ownership information to the website? So that's a stage we were in 2016. And then we have this problem that if you construct a transaction on Web3, then the user does not have the certainty that the transaction is doing what the website says that it is going to do. So the answer to that is ERC. Therefore, if you are transferring token to someone, if the website assembles a transaction for you to send token to someone, then the transaction confirmation page will display it as is. You get a little bit of security, but then we have the problem that we have too many of these possible transactions. Initially, we just think that there will be transactions that transfer a token from one to the other. Then we have the case where we vote. Then we have the case where we collateralize some assets. So we come to the point that we need to write many ERCs, and to the point where we need a visual. Some of the ERCs have to be so complicated that displaying what are the value of these transactions is not sufficient. If you are transferring Kitty to someone, you want to visually confirm that the Kitty you are sending away is the Kitty you see on the web browser. So we come to the point that we have to hard code something into MetaMask, and there was a stage of end of 2018 and now. So observe this process that we started with the smart contract, and we get in the user interface with JavaScript, HTML. We put them on the website. Then we have the security boundary issue. We ask the user if the user wants to send information to the web. Then we write ERCs. Then we write a lot of ERCs. Then we hard code stuff into MetaMask. This is the process that I call crawling the design space. That is, we have intention to solve a problem, then we hit a technical problem, then we work around it, and we have a new solution. New solution begets new problems. So I would introduce another thinking. That is, how about we look at Web3? How about we look at what people want from Web3? And then how we have this, and we have this in our mind, like a Northern Star, or in here, Southern Cross, doesn't matter. So we have the star chart so that we know we have a way to evaluate if our solution is designed properly. So the star chart is what I call TIPS, T-I-P-S, trust. So people would talk about Web3 as a trust-based network, which means if you think about currently security is the secure connection SSR already allow us to access to Facebook and be certain that we are looking at Facebook, not other website, but you still get fake news, right? So it means that a secure connection doesn't provide truth. Trust is what people will think Web3 can provide us. So let's say if you are browsing Web3, it says that you have balance of $7,000. It's not fake news. It's from blockchain truth that says you have $7,000. So trust is number one. And then we have interoperability. That means Web3 is going to be a decentralized network with components built by different companies. And we have this hope that they actually would work together. It has never been done before. Different people build different components. It would not work together. Web is the only case that it actually worked, but then it became Facebook. So interoperability, second thing we look at like that. This is what we want from Web3. Privacy. So let's say if you want to check out, on a website that sells you stuff, and the website says that you have balance, $1,000 balance, and you certainly don't want website to learn that you have $1,000 balance, but you want to see that because it's good for convenience, right? So how can we achieve this? How can we log into a website with our Ethereum address and not telling the website outright how much Ether do we have? And then we have security. That is, how do we guarantee that user, when they create a transaction on Web3, the transaction represents what they really want. So these are the Northern Stars. These are the things that we look at when we build a solution. Following this, I'm going to enter example. I'm going to show example how current Web3 design lack maturity in these areas. And then we will talk about how to mend it. So this is imaginary website. This is my concept. This is called Hello Kitty. So I was thinking, how do we make a Hello World version of dApps? Okay, this is Hello Kitty. So the idea is you write a website, and if the user comes to your website with the kitty, if the user has a kitty token, then you render this kitty on the website with a matching background. So this kitty has a shovel, and he has flies around his head. That means he's fitting to be in the garden. This is give a garden. This is an idea that you match the kitty with background. Okay, so this is an extremely simple idea, and let's evaluate tips. With this simple idea, actually, we can only okay, back to this. So this is how Vitalik would have envisioned this is to be this website to be done. That is, the website goes to the web browser. The browser goes to the website web server. And the web server gives the user a bunch of HTML and JavaScript, and that JavaScript guide users to access users' Ethereum node, which gives users information like what is the color of the kitty, whether or not the kitty has flies around him, whether or not the kitty has shovel. And then the user will draw the kitty here. Yeah, this is how Vitalik would envision it have to be. But this is most likely how it will be done. This is that the website gives user a bunch of HTML and JavaScript. And JavaScript does only one thing. It has only one line. It says, what is your Ethereum address? And the user submit the Ethereum address. And the website would go to their Ethereum server and find out what does kitty look like? Does the kitty have a shovel? And draw the user interface. So you can see in this case, the user actually does not need Ethereum. The user does not need to access blockchain. So how does the user ascribe truth? The answer is user simply trusts the website. This is how it is today. So now if you have a CryptoKitty, where is the picture coming from? CryptoKitty.com. Is it as trustworthy as blockchain? And whether or not it comes from CryptoKitty.com, you don't know, unless you know how to use HTML inspector. So let's look at let's look at tips to trust. Number one, the user does not know if what he see on the screen is his token, or whether or not it comes from blockchain truth. In fact, if this is a static web page, the user wouldn't know, unless the user happens to remember what his kitty looked like. And second, if you look at interoperability, I chose the kitty with fly for a reason. So imagine this thing was built in 2017 when none of the kitties has fly around his head. So one day this CryptoKitty thing, token issuer decide to upgrade the smart contract and provide this new type of kitty. How does the CryptoKitty.com token issuer ensure that the kitty is correctly drawing the new websites? If it's a website that only understands old kitty, it probably will draw a message says that your kitty is not recognizable on this website. So we have interoperability issue where decentralized components would not work together with each other unless CryptoKitty has control over every website that uses kitty and can force them to upgrade, which we're not going to get. And if we look at privacy, suppose the user have 100 kitties, okay? Some of them $1 million worth. And the user only select one of the kitty because he only want to play with this kitty. Then in order to display a huge list of 1,000 kitties, because this guy has 1,000, the website necessarily already know this guy has 1,000 kitties. And then which kitty has they can look up the value of each kitty. So privacy is an issue here. And then we last look at security. We don't involve transaction in this screen, so security will be evaluated later. Yeah. So we see that currently it's not mature to solve our expectation. So here's a solution. This is called an enclave. It's a space. It's a virtual machine. It's a space on the web that runs token code. By token code, I mean some software code that is written by token issuer, the same guy who wrote smart contract. So the guy who wrote smart contract, people naturally trust them because you need a trust anchor. Blockchain doesn't provide trust, blockchain only forward trust. So the same guy who wrote the CryptoKitty smart contract wrote this code to render a kitty, and it runs in token space. And then this token space here is a upper layer of the website. The website is in the behind layer. The background is there, and this runs in a secure enclave, meaning that to access information related to the token, you have to go through a security interface. So the look will more like this. So it's still kitty in the garden, but if the user wants moves mouse over the enclave, then enclave is highlighted. So the user knows that this part is true. This part accesses blockchain information and is not rendered by the website. So with a security enclave, the process goes like this. First, the website provides JavaScript and HTML, which asks user, you got a kitty? And the user say yes. At this time, user will choose a kitty from his 100 or his litter. And what other kitties the user have, the website will not be able to learn. And then the website will ask, what is the color? I need this for choosing the garden. And the code runs in this token space, which is written by the CryptoKitty issuer, is able to provide the color information. And then the website asks, okay, says, okay, it's great. So I will render background. This is the background. So here is the process. So notice that the way the website acquire token information is not that I learn your address, I learn your token ID, I inquire smart contract. Rather, instead, it inquires a secure environment. And this environment dictates the rule how token can interact with the website. So if we look at trust, tips, trust, if we look at trust, the user knows that this code running here to render the kitty is signed by the CryptoKitty.com issuer, and it uses blockchain data. If you look at privacy, the website doesn't learn anything else about kitty unless the code here dictates that this information is available for the website. And if we speak about interoperability, if CryptoKitty.com has a new token that has the flies around his head, kitty's head, then they can update the code that runs in the security enclave. It's a little bit like apps running on a mobile phone, and it would be updated, and the website doesn't have to update. And if you think about security, we will come to that later. So we see that this design is more mature than previous one in solving TIPS, what we expect from Web3. So the technology that enables it is called TokenScript, and currently it's under a Ethereum Oasis open project umbrella, which is a standardization process by Ethereum Foundation. So we are the main developer of TokenScript technology that enables this kind of thing. Here, what you are seeing is a typical TokenScript that is a signed document provided by token issuer. It contains information about how the data and token should be processed, the type of the token, the access control, which website can use this token without requesting permission, which website will ask user for the permission to use such a token. And you have these actions, like actions and cards. Cards like CryptoKitty being drawn in the previous screen is a card, and action is what you can do with the kitty. This is just the very high level look at how TokenScript is. So security enclave, which is running on a website, but not belonging to the website. It has this in our previous slide. It has this has joined the kitty is defined here in the cards. Right now we're experimenting with HTML and JavaScript, but we will go to other technologies soon. So here we just demonstrated Hello Kitty, and with that understanding, we go to the next one, slightly more complicated but more productive. So this is a website that is more realistic. It's modeled after the Melbourne startup called Car Next Door. So the idea is, if you imagine that you are in 2025, imagine blockchain is already everywhere, and every car owner would have a token that represents his ownership of the car. So Car Next Door is a website that allows you to rent a car out and earn $100 revenue per day. And of course, at the cost that you're not being able to use the car in the interim. Yeah. So on this website, this is a car token here, and it is rendered with token script. It runs in the security enclave. And it has the information that only the car owner can see. So you can see that this here, the car vehicle identification number is displayed here, but the website doesn't know it because the website doesn't have access to this portion of information. And this is a sign-up process where the user is able to produce a transaction, use his car ownership token to obtain a token called car rental listing, which generates $100 per month revenue, or per day maybe. So this is a sign-up process. So this would be how it happens, how the process is. So this websites, this case, you see that both the user and the website has access to Ethereum nodes because it's serious business. They need to validate information. So the website will start like this serious business to actually own a token, car, and the appropriate insurance. And this token would produce a policy attestation to show that this car is existing and properly insured for strangers to drive it. And this will be provided, maybe in zero knowledge proof, but let's leave out the detail. This is provided by the security enclave. And the user, the website is able to inquire their own connection to the Ethereum blockchain and to verify this insurance being correct and not expired. So that this car is eligible for joining the car next door program. And then at this point, the website is car next door. It is also each token issuer. It will provide a token script by car next door, which helps the users to assemble a transaction to get car rental listing token. So here, there's a token script being developed to deliver to the user, and the user's browser, that browser, future that browser, is able to use that to construct a secure transaction. This is the first time we talk about transaction security. Then it looks like this, that the client, that browser, will take the token script and check if it has been correctly signed and endorsed by the contract of car rental listing. It could even be endorsed by the car ownership token contract as well. This is a level of trust here. So suppose the user trusts the token script, which is the code that securely assemble transaction, then the user will be asked to make a transaction. And this is a transaction where the spending is zero because this is a free sign up. And the car owner is going to use a insurance token, and he's going to get a rental car listing token. So the user will know before they participate in the smart contract transaction, before they send a smart contract transaction, what the user will get in the end. And then the user will have two tokens, previously car, insured car token. Now this is a new token, car rental listing. The user will be able to use this token with the functions like setting which days the car is available, or getting revenue from this token, or even sell this or collateralize this, or make a security out of this. So the core technology being demonstrated here is it requires kind of mind shifting. Previously, we look at website Web 2. We look at the interaction between a website and the user, and whatever user is able to provide, that's the interaction going on. If you look at the future Web 3, given that we have the TIPS, the trust, interoperability, privacy, and security requirements, the model here is not just the user interact with the website. The user do interact with the website, but also through a token. And that token has to be run in a space on the web that is different than the website itself. So this is the main thing I'm talking about today, about how do we make Web3 secure. And this is a technology being developed. Unlike Brave, it's not a product already. We do have a product, which is AlphaWallet, which uses the technology, but we have not been have not produced a product to make this live on the web. So this is more like an early stage communication with the community. So we get a feedback that we're on the right track and people understand what we're working on. So this is the thing here. And that's basically what we talk about today. And the exact work going on around TokenScript Enclave is available on the website tokenscript.org. And you'll see that we don't have a MetaMask support so far, but we do have wallet support, which only have partial support of what we're talking about today. Yeah. So this is just today's talk about security and. Yeah, please.
So what provides the enclave JavaScript?
So
Is there a browser add-on?
yeah. So yeah. So currently, the way we implement it is we modify the browser code to create a virtual space in it, but it's not really secure because we still cannot prevent the website to inquire the memory space inside. So no, it's not okay for the website to inquire the memory space of the token, because if your token wants to produce a zero-knowledge proof of something, and the website can access it, what's the point of having the zero-knowledge proof, right? So there has to be clear segregation. That's the point we have not achieved yet. So our vision is to achieve it through a alternative technology called WebAssembly, and which creates a memory protection. So you cannot inquire the memory in the WebAssembly from the website, which will allow us to make it even more secure, which is undergoing. So actually, we don't have a working. Yeah.
Oh, sorry, I meant more like, what do you envision it being? Would you envision it being built into a browser, or like?
Oh yes. So we will see if we can make it as a MetaMask plugin, and because we are a mobile wallet provider ourselves, of course we can modify the browser because we produce the browser. So the technology enables that is going to be a virtual machine technology, and very likely WebAssembly with a different interface than typical WebAssembly, more elaborate interface.
So you will put the Ethereum node inside the WebAssembly, or the WebAssembly can actually communicate with your local node?
So the code in WebAssembly has direct access to the blockchain, as well as any cryptographic attestation locally available. And then it can generate proof to the website. The website can verify the proof either by evaluating the amount of work that has been done on it, because you can evaluate SPV proof and evaluate the amount of power that's burnt in order to produce such a proof. Or they can go back to evaluate their own blockchain.
Another question is, so for people to trust that, people have to trust the WebAssembly doing the right things. How can we prove that?
So you have to. There is no way to create trust out of a void, right? So basically, when you use software, you kind of trust the software, and there's a competition between software. If one software failed to deliver the level of security, the other software will win. We have an open source technology, and we have a reference implementation, which means users probably will trust us that we will secure the WebAssembly environment. Now, the other point of trust is whether or not the user trusts the WebAssembly code is actually doing what it was supposed to do. What if it has whitelisted every website? Therefore, the token is automatically available to every website, for example. So that is something also the user have to evaluate, is the token trustworthy? So having a Bitcoin in your wallet is different than having a ICO token, right? So there's different level of trust implied with token issuer. So the trust of token to the token issuer is still an issue. It's still an element of the future Web3. The part about, let's say, if you go to the future Web3 Facebook and you say fake news, whether or not you say fake news, it still depends on what kind of token you have and whether or not token is trustworthy. It sounds like still like we are coming from Web2, we don't trust everything. Now we come through to Web3, we still have to find out whether or not token in our wallet is trustworthy, but it's actually improvement because now there's a way to ascribe trust. Previously, there wasn't. Yeah.
Any other questions?
Yeah, please.
Why Ethereum, not EOS or whatever else, Cardano?
Yeah, exactly. Very good question. So TokenScript and the security enclave technology is one layer above blockchain. If you imagine blockchain being a layer of a smart contract addresses and proofs, then token layer is about business. Token layer is about smart contract layer is about which is your smart contract address, what transactions you can do, and token layer is about whether or not that transaction represents you owning a token, whether or not that token represents a car or represents your identity or whatever. So we run one layer on top of Ethereum, and it is a layered design, meaning that if we see EOS being the final blockchain that actually became the new internet, then we are still one layer above that. We can just adapt to that. So it's not a tight bind. Yeah. Yeah. DK.
What is this new blockchain? If it's affected above that layer, if we just put on a centralized database, because it will either work or if someone messes with it, the keys won't work. So
yeah, exactly.
That means the database is
you can have
by definition.
You can have, for example, you can have a attestation, which is signed message from a tester, show that you have certain rights. And you will be able to use this right without using blockchain. So certain logic would not require blockchain. So there will be a subtle thing like when does this logic enter blockchain and when it's just floating there with the existing cryptography, given that you already trust the token issuer, right? So the point of connection is market. So if you do not need your token to be transferable, for example, attestations typically are not transferable. If you are a business owner, you have attestation that you are able to run business, or if you have you are individual, you have attestation that you have own voting rights. Then these things typically does not enter the market. So you do not have to trust a independent entry that can carry out the market activity like DVP, what do we call in the bank DVP, like delivery versus payment market activity. If you don't require this mechanism, you should not let this, you probably should not let this thing be on the blockchain in the first place. So token script is actually, because it's one layer above, it can finalize, it can make process work, even if some of the process is not on the blockchain because it's not needed and some of the process is, or that the process has nothing to do with blockchain, still work with secure enclaves, still work with cryptography, but at a certain day, when they plug into the blockchain, they can naturally plug it in. So that's how it works. So that's really a spot on question. So that shows that if you go to the token layer, from blockchain layer to token layer, then the under layer doesn't have to be blockchain. That's really insightful. Yeah. Ultimately, it's what business need. So do we need the part market provided by blockchain? Do we need it to be supported by entities that has no integration with you, but integrate some to blockchain somehow? That would be the real question. Yeah.
Thank you, Weiwu.
And James, you wrote down this 8th beer, right? No. Yeah, I don't know.
Thanks again, Courtney, for the space and for sticking around. Cool. All right. Yeah. Done. Yeah.